All right, folks. Well, let's see what we can do about Lab 4. Hope it was a decent break for everybody. Again, we're trying to pick up where we left off in Lab 3, right? So in your Lab 3s, you got a bunch more work done in your yacc files to go through and start doing all the wonderful, joyous, context-sensitive checking. We're going to add a bunch of new features to the language, a bunch of new things to check. And again, this is all building on what you've got working from the first 3 labs. And then once this is working, that'll kind of be the end of the new features for the language, and we'll start focusing on the translation to the target language. But again, if you go to the language description page, again, usual idea, right at the bottom is that table of lab by lab changes. And so now we're on to those revisions for Lab 4. You can read them through in detail on the language page. I'm just going to kind of summarize them for the lab session. Again, hopefully most of these are reasonably obvious from a what they're supposed to be point of view. It's just a matter of getting them to work. So let's see where we can get to here. We've got 2 numeric operators that we're going to add now, addition and subtraction. The usual associativity, so left to right, and their equal precedence. So we're just adding one new layer of operator precedence here. And they're binary operators, so these aren't the unary, positive, negative. This is just straight addition and subtraction. They can only be applied to numeric values, so whether it's numeric literals or numeric variables or the results of the lookups that return a number. So they can be applied to any of those. Essentially, they can be used any place where another numeric value can be used. So now what you're looking at is going back into your grammar from Lab 3 and saying, okay, well, every place where I used to be able to accept, whatever kind of numeric value is, now we want to accept our numeric expression, if you like. So this can either be, additions with plus and minus, or additions with plus and subtractions with minus, or it might boil down to a lookup, or it might boil down to a variable, or it might boil down to a literal. So you're going to have to work out the grammar rules that are going to work for that and modify your grammar to support those. So that'll be one of the bigger ones with respect to grammar or modifying the grammar. A bit of a tweak to your string literals. So we'll allow them to have 2 simple escape sequences in them now. So you can use a backslash and a single quote to indicate that you want a single quote to appear in the string literal. So we've got that. And since we're now using the backslash as an escape character, we'll have a backslash to indicate that you want a backslash character in your string literal. So we've got those 2 escapes that we'll add to our string literals. Other than that, they should stay the same. And one of the biggies that's going to impact a couple of other things here is that now we will allow function definitions and function calls. So you can have any number of function definitions. The idea is they come after the map size declaration and before that start token. So that's where all of the function definitions, if any, have to appear. For each of them, the syntax is you use the keyword function and then whatever name you want to give it, and that follows the same rules as our variable identifiers. A list of parameters that are comma separated, so it's data type, parameter name, comma, data type, parameter name, etc. And then a colon and the return type to end it. And if the function does not return a value, then it's got a return type of none. So kind of the equivalent idea of void in something like C, just a little different syntax. Then a begin and an end, and between that, any number of statements you want. If it does return a value, then it must include a return statement and whatever value it's returning. So there's the a no return statement if it is not supposed to return a value. So there's the idea, any number of statements in between. So the function definitions are reasonably intuitive. The function calls are also reasonably intuitive. If it's one that does not return a value, then you simply issue your call and pass it whatever parameters, again, comma separated. And if it's one that does return a value, you can use it within an expression or an assignment statement or anything, any place where you would use the matching data type. Now, of course, this does mean that you have to make sure that when you make a function call, that the function's actually been declared, that you pass it the right number of parameters, and they are of the right data types in the right order. If it returns a value, you've got to make sure that the return value is used appropriately, right? The type matches with the way you're using it. So there's lots of new type checking involved in this. And in all likelihood, you're going to be going through and saying, okay, well, I better come up with another table keeping track of my functions. All of our functions are global scope. So it's just saying, okay, what functions have been declared? What's their name? What's their return type? And what do they expect in the way of parameters? How many parameters, what data types, in what order? So you're going to be going through and checking that things have been defined before they're called and making sure that all of the types match both for parameters and return values. So fair bit to do there. Obviously, you're going through inside the function statements, making sure that if they use an identifier that it refers to either an accessible variable, which I'll get to in a second. Actually, I think I've made all the variables local, so that's actually not the case. So it should refer to either a local variable or a parameter. So variables, and we'll get to this, might as well duck down to this now. Variable scoping rules are changing. Variables are now local, not global. So if you declare a variable within a function, it's local to that function. So you can have a variable x in all of your functions if you like. Variables that are declared inside the start-finish block are local to that block. So now you've got scoping to worry about when you're looking for your different identifiers. If you see an identifier used, you have to see if it's either declared within the current function or the current start-finish block, or whether it's a parameter that actually exists for that. And again, we've got the usual checking to make sure that the names don't shadow other names. So you can't have two parameters with the same name. You can't have a local variable with the same name as one of your parameters. Your parameter names or your local variable names can't shadow your function names. So fair bit of checking just to make sure that you're not overlapping any names that are in the same scope as you're in right now is essentially the idea. So again, you can do this however you like. You can add an entry to your symbol table for your variables that specifies what scope it's in, or for the parameters for that matter, specifying what scope it's in. And just when you're going through looking things up, look for the variable in the symbol table with the right name and the right scope. But again, how you want to handle that is pretty much up to you. Again, we don't have nested scopes to worry about in this case beyond just either you're in a function or you're in your start-finish block. So it's a relatively simple set of scoping rules, but we do have scoping rules to worry about now. So that will be the last biggie to try and keep track of. So now you're probably looking at one table for your functions, like a symbol table for your functions, a symbol table for your variables. You might be looking at how you want to structure your parameter handling, but I will leave that to you. I think that's all of the changes that you need to worry about. And again, the big thing is going through, making sure that we've got our grammar updated so that it still works correctly for the previous desired functionality other than the changes to the variable scoping rules, and that it now supports all of these additional features. So again, once we've got through this one, we should be in pretty good shape for the language structure, and we'll just start looking at the transition to producing output in our target language. I think that's everything I wanted to go over for this one. Let me know if you've got questions.